we're talking about equations, and you pick the numbers. So we're going to find the rate of change. We're working our way towards finding the rate of change when we pick the numbers. And we're still going to be talking about linear. We're still going to be talking about functions, things like that. So here is an equation where we have y equals the absolute value of x plus 3. And when we're talking about you pick the numbers, you get to choose whatever numbers you want. There is no assigned number that you have to pick. There are some caveats, and I'll get to that in a second. So what we're saying here is y equals, and because I get to pick the value of x, I'm going to be substituting the value of x because x is the independent variable, and I'm going to pick a value for x. That will give me the dependent variable. So I'm just going to pick 5. I picked 5 because why not? So I pick a 5 to put in here. And the absolute value of 5 is 5 plus 3. And the output or the dependent variable is 8. My gosh, I've lost the ability to speak. And then I pick another number. I pick 3. Okay, so I'm going to substitute the value of 3 into this equation. And the absolute value of 3 is 3. Plus 3 is 6, so the dependent variable is 6 when the independent variable is 3. So I get 6. And now I pick 0, because 0 is one of those numbers you should pick all the time because it's a nice, easy number. I pick 0, absolute value of 0 is 0, plus 3 is 3. So the output is 3, or the dependent variable is 3 when the independent variable is 0. So with those 3 numbers, usually 3 numbers is enough. And I could go over here and say, okay, when I went to 5, I got 8. And when I went to 3, I got 6, because those are the ordered pairs. And when I went to 0, I got 3. And I can say, okay, well, this obviously is a function. And it looks linear to me, so I should be great. But here is the kicker. Just to check, I'm going to go ahead and check, because sometimes equations act differently when they go into the negative area. So if I pick a negative value, like negative 3, it should be on this line, right? But when I put in negative 3 into this equation, the absolute value of negative 3 is 3. And 3 plus 3 is 6. So when I input, or the independent variable is negative 3, the output, or the dependent variable, becomes 6. Wah, wah. Let's see, negative 3, 1, 2, 3, 4, 5, 6. Uh-oh. And then if I put in negative 5, well, negative 5, the absolute value of negative 5 is 5, and 5 plus 3 is 8. So when the input is negative 5, the output is 8, or the independent variable is negative 5, the dependent variable is 8. All of a sudden, I get a different picture. So what I assumed was that my graph is going this and continued on that way. But what I find out is that this is all wrong. My graph actually goes back up like a V. This is because this is an absolute value equation. They have a V kind of shape. But what this is, the reason why we bring this to your attention is because, yes, you get to pick the numbers, but you need to pick at least one negative number just so you make sure you don't have any mistakes going on, or that something that sometimes can only be shown when you go into the negative numbers isn't affecting this graph. So I pick a positive number, probably pick 0, and I'm going to pick a negative number every time because that makes life easier. So let me show you what I mean. By the way, this is not linear, right? This is a function, isn't it? So we've learned about those things. This is continuous. We've learned those things before. Okay, so here's another equation. I have y equals 2x plus 1. And I'm going to take x, and I'm going to be substituting the value of x. Now, I get to pick the numbers. So the easiest numbers that I can think of, 1, that's a pretty easy number, right? I'm going to pick 0 because 0 is always easy. But remember, I have to pick one negative number, so I'm going to pick negative 1. Because I'm going to try to keep it simple. So now what I'm saying is these are my independent variables, and so when I plug in 1 or substituted 1 into my equation, 1 times 2 is 2 plus 1. And by the way, if you're confused about this, this can all be just typed into your calculator, can it? You can just put in 2 parentheses 1 parentheses plus 1, hit enter, it'll all be done in your calculator. And I get 3, right? Then I can go and hit second enter, so that'll be in my calculator, and I'll put the new value 0, because I'm going to input 0. 0 times 2 is 0 plus 1 is, the output is 1, so the dependent variable is 1. And then finally I'm going to put negative 1 because I want to check how my graph behaves in the negatives. So 2 times negative 1 is negative 2 plus 1 is negative 1. So I've done that. Let's go check my graph out. If I go to 1, I get 3. I go to 0, I get 1. When I go to negative 1, I get negative 1. And again, I can see that my graph is going to be linear, right? But again, not everybody, or you at home might not even have graph paper, right? So how do I do this if I don't have graph paper? Well, this is where we talk about you can do stuff like find the rate of change. And what I'm looking for in the rate of change is the change in y over the change in x, like we've been learning. And so what that means is I'm not looking for the y's, I'm looking for the change in the y's. I'm not looking for the x's, I'm looking for the change in the x's. And what they mean by that is when I go from 3 to 1, how much does it change? Well, this gets smaller by negative 2. When I go from 1 to negative 1, this changes. It changes by negative 2. On the other side, when I go from 1 to 0, it's changing by negative 1. From 0 to 1, it's changing by negative 1. But I'm not looking at just the 2's and the 1's. I'm looking at the ratio between the negative 2 and the negative 1. The change in the y and the change in the x. And when I put those together, I get negative 2 over negative 1. And the other one is negative 2 over negative 1. And I would agree that these are the exact same. So they're the same, but they can be simplified. Negative 2 over negative 1 is 2 over 1, which can be simplified to just 2. You don't have to keep it as a ratio because all whole numbers are considered to be fractions if you added a 1 underneath them. So the rate of change for this, the ROC, rate of change, is 2. Cool. So this is linear, and because the rate of change is constant, and this is linear because we graphed it, but we don't always have time to graph it. So the only change to this would be, here's the equation again, I copied it down here, is you say, okay, you said to use 1, 0, and 1. Well, if I put 1 and I substitute 1 into this, I'm going to be substituting a 1 in here. The problem is that this turns 1, if I put a substitute of 1 for the independent variable, I end up with a fraction 1/3. That's horrible, because I have to do 1/3 plus 2 is 2 1/3. How am I going to graph 2 1/3? I'm going to have to guess, right? So maybe picking sometimes the easiest number isn't 1, or 0, or negative 1. Sometimes you have to pick a number that works better. And in this case, I can see that the denominator is 3. So if I can choose numbers that are divisible by 3, this will work out much better. So instead of picking 1, I think I'm going to pick 3. Because if I substitute 3 into the variable, for the independent variable, 3 divided by 3 is 1, and 1 plus 2 equals 3. So when I input 3, I got out 3. That's kind of cool. 0 still works, because 0, when you put 0 into an equation, 0 over 3 is just going to be 0, and 0 plus 2 is just going to give me 2. That's awesome. And now I have to pick a negative number. If I pick negative 1, I'm going to end up back in that fraction again. And I don't want fractions, so I'm going to choose negative 3. When I substitute in negative 3 into the equation, negative 3 divided by 3 is negative 1. And then I add 2 to it, and I get 1. So I've chosen numbers that make it easily divisible because I looked at the denominator of the fraction. And now I can graph this, 3 and 3, and I'm going to put that in a different color. And 0 and 2 and negative 3 and 1. And again, I can see from this picture that this is linear. This is a straight line. This is also a function. This is also continuous based on what I have there. But what I want to check again is we're looking to see now at the rate of change. And again, the rate of change is going to be the change in y over the change in x. And again, I'm not looking at the y's, I'm looking at the change in them. That's not a y. I put an x there. The change in y and the change in x. So as I go through this, I say, how is it changing from 3 to 2? It's going minus 1. How is it going from 2 to 1? It's going minus 1. So the change there is negative 1. And from x, I'm going from 3 to 0, that's minus 3. And from 0 to negative 3 is minus 3. And so again, I'm not looking at those individually. I'm looking at the ratio. That means I'm looking at, I'm going negative 1 and negative 3. That ratio between them. Negative 1 and negative 3. So negative 1 and negative 3. And the other one was negative 1 and negative 3. And again, these I can already tell are the same. So the rate of change is the same. But I want to simplify this. The negative divided by a negative is a positive. And so I get a positive 1/3. So my rate of change is going to equal 1/3. And because it's the same, constant rate of change means the line is linear. So I didn't have to graph it. I just had to find the rate of change. Cool. All right, so we made one a little bit harder. So here's a little bit more difficult. I have y equals 2/7 x plus 2. You say, well, x isn't in the numerator, so I shouldn't have to worry about it. But I'm going to have to multiply x by this fraction. And so if I choose a 1, well, 1 times 2/7 is going to be 2/7, and I'm going to end up with 2 and 2/7. How do I graph 2 and 2/7? I'd have to guesstimate again. So again, this is one of those equations where usually I pick 1, 0, and -1, but this is an equation where I need to pick a number that I know is going to be divisible by 7 so that it ends up working out nicely. So what I'll pick, I'll just pick negative. I'll pick 7, I mean. If I substitute 7 into this equation, I get 2/7 times 7. The 7s are going to cancel to 1, and I'll get 2, and then add 2 to that, and that'll give me 4. Cool. Now, 0 still is my standby. I probably use 0 like 99.9% of the time. I pick 0, I substitute 0. Well, 0 times anything is 0, plus 2 is 2. That worked out nicely. And then finally, I have to pick a negative number. Well, if 7 works, then -7 should work, because we know that that's divisible. So I pick -7. 7 times over 7 is going to reduce to 1, but it's a -1, and 2 times -1 is -2, plus 2 should give me 0. So, again, I'll grab it just to show you. So I got 7 and 4, and then I had 0 and 2, and -7 and 0. And again, you can see with 3 points, I can show you that this is linear, right? But the other way we can do that is if we just do the rate of change, and that's a lot more simpler. The rate of change is the change in y over the change in x. I'm like a broken record because it's important. Change in y and change in x. So I look over here and say, in my y, it changes 4 to 2, it goes -2. And 2 to 0 gives me -2. And over here, 7 to 0 is -7. And 0 to -7 is -7. And again, I'm not just looking at those numbers, because we showed in the last video that sometimes they're going to jump around. I'm looking at the ratio between the change in the y and the change in the x. Ratio between the change in the y and the change in the x. And these ones are, again, both the same. So the rate of change is constant because they're both the same. That means I didn't have to graph it. I can just say, this is going to be linear. But again, I want to simplify because a negative divided by negative is a positive, so the rate of change is 2/7. So the last thing is here is, did you notice anything? I don't know if you noticed anything while you were watching this video, but let's go back and look. I said the rate of change was 2/7. Do you see 2/7 in the equation? You're like, oh, wait a second. The 2/7 is right here. The rate of change was 2/7. Are you saying that the coefficient is the rate of change? Get out of here. Let's go back and check. Can't be. The rate of change is 1/3. That's not 1/3. Wait a second. X has a coefficient of 1. 1 over 3. Is that not 1/3? Then why do we do all this work, Mr. Craig? Well, because this is the way you learn. So you're saying to me that the rate of change is the coefficient? Yes, I am. You can actually find your rate of change from an equation without worrying about this. Just look at the coefficient. So that concludes this video. Go do some of these problems. They should be easy now that you know this.